Welcome to EyeOpener, powered by Siemens. And now, your host, Gugan Sanger.
So, James, is this where language models come into place?
Yeah. Okay, so we can talk about that. So the conversational PDM thing, it has mostly been a metaphor, right? Okay, in how we've thought about, and organize things. And the reason it's sort of mostly been a metaphor is that AI is not really an agent, or not a very functional agent, okay? And I said its superpower, has been looking at scale, right? So just the ability to do what we'll talk about in a while is sort of, in some sense, straightforward analytics at big scale and report what's going on for then the humans to make the sensible judgments about, right? The interesting thing about language models, right, is that they allow you to move away from this just being a metaphor, right? They give you the ability to, in some sense, personify that agent, right? And give it the things that language models allow, right? Which is the ability to bring common sense to bear, okay? And, a huge amount of background knowledge, and to reason over complex information, and to communicate that with the user in a conversation in a very natural way, right? So, and again, many companies have this idea in a way, obviously, right? But the AI in Sensei moves from being something that just creates an alert, okay, to being something like ChatGPT, that understands about all your machines and everything that's ever happened to them and everything you've ever done as the user, right? And can bring all of that to bear at a particular point in time and just answer whatever questions you want, okay? And so it's just very nice. So we have this metaphor for many years, and then, the advances that happened in the AI in the last 12 months just opened the door to making that really quite concrete and actually representing it actually as a conversation in the application in a very real way, yeah. Okay. So that's quite a fun thing to think about. Yeah. Yeah,
I was going to say this whole language models. It's very interesting to come up with that concept around it as well, and how it comes into place. So,
yeah. I mean, it's like language models is just interesting in the sense, that there is this basic capability there, and the doors have been open to that, right? And then, lots of companies are trying to figure out how it fits in with their application, what they can do with it. We're in a quiet period at the moment. Yeah. Companies are doing this, and you will see the fruits, In some ways, Sensei is not perfectly set up for language models because we're not primarily like a text-based product, But obviously, in the way that we discussed, there's a way that it does slide in nicely. Yeah.
Yeah. And what would you say are the main, if we talk about language models, what would you say are the main benefits of having those? I mean, how does having a language model assist with the process?
Well, in many ways, right? But I think of language models. It may not be formally true, but I think of them as being, a very rudimentary kind of artificial, proper artificial general intelligence, right? It's the only sort of technology that I've used, which is bringing with it a complex model of the world, an understanding of the user, an understanding of the kind of thing that it is, that it's an agent in an application, what have you, right? But and then an understanding of machines, the kind of things that happen to machines, et cetera, right? So it's being able to tap into that broad, world model that it's got inside, and the ability to connect that to local and specific knowledge, private, to do with your machines and all of this kind of thing, and previous interactions. And then, just to be a master of communication in the thing that's the most natural way to communicate for humans, and be able to do that, bilingually in, pretty much any major language, right? I don't know. And so in our particular case, it takes the AI, from being a thing that raises alerts that in some sense is a little dumb, right? Even though, the algorithms may be nice in different ways, right? To making it properly sophisticated and useful. I mean, it really is a monumental difference. And like I say, it's not, there are complications for inserting this into any product, right? Yeah. And the complications we have, of course, is, how to say, right, the ambivalence of these models to the truth sometimes, okay, and how to connect it up to your sources of data in ways that work properly, right? Okay. So there's all kinds of complications, but the basic ability there is totally incredible and world changing, etc., etc.
Yeah.
And I think would just be useful in the way I described, right?
Yeah.
But the details of that remain to TBC, right? We do research and UI development, and we see, right?
So, James, I know we touched on this topic of organising the system to avoid complexity and to build trust. So, it'd be really great for you to just give a bit more information about that and to get your insights.
So there's various different ways that the user can do this, right? So there's a sort of traditional, straightforward approach, which is they set thresholds, okay, or rules or things like this to sort of say what matters, right? But if you want to do something more sophisticated than that, there's two things that one can do. So one can configure the algorithms, right, or do things on that side. So it's choosing algorithm parameters, deciding what data to train the algorithms on. So you might want to say, oh, this is good data, this is bad data. Okay, you might have different algorithms to choose from, right? Okay, this kind of data, I think we'll use this one, we'll use that one. Okay, so there's a certain sort of complexity there. But when you're making those decisions about what algorithms to use and what parameters, you're basically implicitly telling the system what you care about.
Okay.
And what you don't. The other way that you can do it is you can put this complexity in the data transformation, right? So you could have just one set of algorithms that always do the same thing. And in the data transformation stage, you remove things that are not of interest. So, for example, sometimes series have dropouts, right? Just goes to zero, whatever, right? So somebody, instead of having an algorithm that can handle dropouts that they turn on, just remove the dropout, right? Okay. This kind of thing. So you've got your data coming in. You have some data transformation step, right? Where you can essentially clean it up, remove things that are not important, leave the things that are important. Okay, then you have your algorithms. Okay, sorry, this is a long-winded way of explaining this, right? Okay, but there's different areas where you can put the complexity. So the attitude of Sensei is to put the complexity in the data transformation and not in the algorithms. Okay, so the algorithms running on everybody's data all the time are pretty much the same algorithms set up in the same way. Okay. What customers do different is they transform their data in different ways. Okay. Yeah, to make it compatible essentially with those algorithms. Okay. So the algorithmic side is just a thing. It does what it does, right? And it's finely tuned to, on average, do something nice. Okay. And then the user has a variety of tools, some manual and some using machine learning to transform their data, such as picking out the things that matter that can be fed into the algorithms and give them the nice results.
Okay.
Okay. So ideally, nobody has to do any data transformation and nobody has to do any algorithm selection or configuration. Right. Okay, but in the real world, you have to introduce something along that path. Sensei decide to do it in the data transformation, right? So the reason we do that is because we think transforming data is easier to do than configuring machine learning models. Okay, for a typical user that we have, they can see the data coming in, they can change it, and it's something else going into the algorithms. Okay, so we think it's a more scalable activity.
Okay.
You know what I mean? Sorry, that's a bit of a long-winded way of explaining that, right? But the complexity left in the system goes in data transformation. We try to support that with nice UI, with machine learning tools and what have you.
Okay.
And the user can use that to effectively direct what the system is doing, should they want to. Right. So a side effect of this is if the analytics is behaving in a consistent way on all of your data all of the time, you can kind of learn what that consistent way is, right? You can come to understand the kind of things that it does, the kind of data it works with, and therefore you can sort of learn to trust it. Okay, which is obviously is an important thing in using any system like this, regardless of whether you're thinking in terms of scaling or not. Okay, so concentrating the complexity in data transformation. If you don't have the complexity in the algorithms, it's easier for users to understand what's going on, to model it, and to trust it, right? Okay, and I think that decision has been important for Sensei. Yeah, it's avoided us going down this dangerous direction of hundreds of different algorithms and and asking lots of the user. So it's kept things simple, important for scaling, and then in terms of understandability of the system.
That's really, really great insights, James. Really appreciate you talking into this and understanding the perspective of organising a system. And I guess I just wanted to go into this whole, what do we mean by doing things in this way of predictive maintenance?
Okay. Yeah, so I can say a few things about this. Right, so like the beginning of the conversation, we were talking about this like traditional approach, right, which is, focused on specific algorithms for specific situations, right? My view in general is that trying to solve this problem via algorithms is not really the right approach to it. It has to be a sort of systems approach, right? Okay, so Senseye is absolutely not a bunch of algorithms in a UI. It is a product, right? Okay, and I described how it's like collecting information from the user, and you have these loops inside it and things like this, right? And they don't work if they're not expressed well and functionally in the UI, right? So one can sort of make that statement that it's much more than algorithms, that it's a system. And a product, but you can also say that it's also much more than a system or a product, right? It does depend on the attitude and outlook and approach of the people using the tool as well, okay? And so maybe it's a slightly caricatured view, but in my head, the traditional way of doing maintenance, is to regularly inspect your machines, like on a schedule, okay, following the manufacturer's instructions or standard advice, and replacing machines on a schedule and all of this kind of thing, right? And you do this, it costs a certain amount of money, right? And you hope that by doing that, nothing will go wrong or nothing will happen. Of course, it always does, right? But your basic view is that it's almost like a box ticking exercise, right? So I suppose an outlook that you could say is a sort of a proper, like a real world predictive maintenance outlook, and certainly the outlook that works well with Senseye, obviously is sort of not that, right? I guess it's to understand that, the world is intrinsically uncertain, right? And crazy and odd and unexpected things will always happen, right? And you're inhabiting that kind of world. And what you're doing over different timescales on a day-to-day basis or on a longer time period, is trying to work with that uncertainty to minimize the chance of critical failures and to, optimize your maintenance budget, right? But what you're doing, so it's a world of uncertainty, okay? And you have a bunch of information that may be useful in helping you decide what to focus your attention on. And that can include the manufacturer's instructions, and kind of standard practice and things like this. But obviously you get the power when you bring that sort of fixed information together, with your experience of the particular machines. You bring that together with the data, right, in a sort of flexible way. Okay, right. And so to me, it's like accepting that, this is it's an uncertain world with all these different kinds of things happen. And what you have to do is to bring this fixed information that you have, like these typical inspection schedules and so forth. You have to bring that, your experience of your particular machines and their foibles and so forth, and you have to bring that together with the data, so that on a daily basis you're focusing your attention really on the machines that use it, that need it, right? And then over time, this adds up to just a more effective use of attention, time, and resources, and you have cost savings and so forth. Okay, but like Senseye to me is a product which is helping you bring those different things together, right? And like making informed, kind of flexible decisions about what you do over time. Okay. But it really is in a sense like a fundamentally different mindset. It's not like fundamentally a box ticking thing where occasionally the weird stuff happens, right? Yeah. It's an understanding. It's just a complex world, and it's like dynamic and more active, proactive somehow, right? And Senseye then is a tool that helps you do that. But you do have to have this different mindset, right? Because Senseye does not support a box ticking kind of approach to things, right? Yeah. Okay. Okay, so I give a specific example, right? I maybe mentioned on podcast before, right? But a typical thing would be someone's doing like regular oil measurements, like looking for particulates, okay? And when they find it above a certain level, they replace the oil, or they decide to go and do investigation and things like this. And this just
Okay.
ticks along as a process, right? But Sensei enables you to notice, for example, that you get trends in the data, right? Whenever you've got particulates in the oil, okay, and you can use those as a proxy for the thing that you would be finding in these tests, and you can trust Sensei to identify those trends in the data. And then only when you get the signal from Sensei do you go and either replace the oil or do an inspection. Okay, so I think we've had one customer who made that particular transition, and so obviously can save people an awful lot of time and money, right? But again, the things we talked about is like designing Sensei in a way that it can be trustable. You can trust it to pick up things like this in a reliable way. Yeah, and then you come to rely on the data for the signals, right?
Okay.
Obviously rather than these more periodic. Yeah. Okay.
No, and it makes a lot of sense because I guess from that perspective, it's not a one size fits all. I think that's one thing to bear in mind as well when it comes to Sensei and the app. Each customer that we have on board, in terms of customer and different industry, it's very much focused on what their need is. That's why in the Sensei world, it's very much, it's not the same each time. Yeah. No, I mean, so the product, as we've discussed, is very adaptable and is designed to be adaptable. I think the thing that probably has to be quite similar across different customers is the attitude to their maintenance process and understanding of the sort of the way in which the application should be used, right? But I guess the main point of talking about this particular thing is to sort of say that I think Sensei do take that bit seriously, right? Okay.
In terms of educating the customer, if we wanted to put it like that, but basically to convey a way of doing things, okay, in the training things that sort of surround the product, okay, and then in the specialist support that they get from delivery people, okay. But yeah, that is a kind of cultural change, right? But it is supported by things that sit around the product, and I think that those things are very important for people having success with the product, right?
Of course.
Okay.
No, brilliant. And James, on this whole Sensei predictive maintenance, from your personal perspective, what are you most excited about moving forward? I guess with this whole change within predictive maintenance, is there anything in particular that you're looking forward to, or? So
I'd say the other thing, thinking a bit more broadly, is just the opportunities that have opened up to Sensei since being part of Siemens, the different Siemens-made technologies that we can work with and make the application works, particularly well with, right? And then also the opening up of different potential markets and so forth. So, I mean, and I can't really summarize all those things, but obviously that transition changes a lot for Sensei, and that makes things very interesting from a business perspective. Yeah. And obviously, hopefully the things you're doing in the analytics are fitting into and supporting the opportunities that opens up.
Exactly. I think there is a wealth of opportunity available, and it really does open the scope up in terms of the potential of Sensei predictive maintenance, and who knows what the future holds. So James, on our previous episode, Jonathan Bonner asked a question for our next guest on the show, and that question is: do you see technology and artificial intelligence unifying in different regions? Okay, so
I'll have to disappoint that I don't really have a very good answer to that question. I really have no idea. I mean, you can imagine AI supporting communication between people in different ways, like fluid, like translation in real time. I don't know, all of this kind of stuff, right? You can imagine those being sort of nice things, right? On the other hand, if the world enters into some kind of AI like arms race, right? You could imagine that, from a political perspective, doing the opposite, right? Okay, if these technologies are not distributed in an equal way between different regions or different countries. But yeah, I have no idea.
Well, thank you, James, for answering that question. I know it's not the most easy question to answer, but if you could ask a question for our next guest on the show, what would it be?
So I guess my question is, when you were growing up, did you imagine that you would end up working in maintenance? What do you think about that? And well, yeah, what led you to this point?
Brilliant. Well, thank you so much, James. And thank you so much for joining me on today's episode. Really enjoyed this whole topic of how to scale predictive maintenance. So thank you once again.
Yeah, it's really nice to talk to you. Yeah, thanks.
Brilliant. Thanks. Thank you to our audience for tuning in on today's episode. Please like and subscribe to our channel and stay tuned for the next one in the series. Thank you.
To find out more, search Sensei Predictive Maintenance.